Hey, eighth graders. So today you guys had this lower part of the table due. Um, and so I have it filled out. So you can go ahead and check over your answers, see if you got them right, where you went wrong, things like that. These two guys right here are kind of tough. So carbon and hydrogen. These two. Okay, so why are they tough? Well, let's look at hydrogen here on our periodic table. So hydrogen's right here. Okay, and we know hydrogen can only hold 2 electrons in that first energy level, right? But we know he has 1 electron. So should he gain 1 electron to have that full valence shell of 2, or should he just give it away? Okay, he can actually do either or. So that one's kind of tough. So I don't grade those 2 boxes. Carbon's the same way right here. Right here. Carbon has 4 valence electrons, right? So carbon has 6 total electrons. He has 2 in the inner energy level, and then he goes up to the second energy level since he's in this second period here, and then fills that up to 4. So he could either give 4 away, right, like a metal, and then have an energy level like helium, or he could gain 1, 2, 3, 4 and have an energy level like neon. So he can do either or. He can give away electrons, or he can take more electrons. Let me see here. But other than that, it's pretty straightforward. There are a couple things that we should be getting to notice. If you guys look, this example, we did a lot of nonmetals. So if you notice the nonmetals, they take electrons, right? How many electrons do they take? They take 3 electrons, take 2. So nonmetals, they take, well, why? Because if we look at aluminum here, we know aluminum has 3 valence electrons, and it will give those 3, right? We know magnesium or potassium here will give 1 because he only has 1. Magnesium has 2 valence electrons and will give those 2 up, right? Sodium is another one. Let's see, that has 1 valence electron and will give that 1 valence electron up. So our metals are actually, they'll become positively charged ions, right? So positive 3, right? Positive 1, positive 2, positive 1, because he's giving away that negative. So if we look at our periodic table here, all of our metals are right here that we talk about, right? We're kind of forgetting about these transition metals right here in this big center block. But our metals, lithium down here to francium and beryllium down here to radium, these are the ones that we're talking about, and they will give up that one. Group 1 guys will give up their 1 electron so they can have an energy level like these fellas over here, the noble gases. The alkaline earth metals, again, will give up their 2 electrons here so that they can come over here and their electron valence levels will be full. Okay, and then our nonmetals are all on the right side. And how do they all begin to look like the noble gases? Well, fluorine, chlorine, bromine, iodine, and acetane. These guys will gain 1 electron. All of these guys in this group will gain 1 electron, making them -1. That would be their oxidation number. Same thing, group 6 here. Oxygen, sulfur, selenium, tellurium, and polonium. These guys will all gain 1, 2 valence electrons. So they'll always be negatively charged ions when they do turn into ions. Nitrogen, phosphorus, these guys will go 1, 2, 3, become -3 charge, okay? So everybody wants to be that noble gas, okay? So you can go ahead and pause this video if you haven't already. Go over and go ahead and check your work. For these guys, and that's what I'm going to grade. For these guys, sodium chloride, magnesium iodide, and potassium iodide. So let's go ahead. I did that on the last video. So let's go ahead and look at sodium oxide, calcium chloride, and magnesium sulfide. I'm going to do this one on the board today. So sodium oxide. Okay. Okay, so when we've been doing this, we're only looking at the valence electrons, right? We're not, if I wanted to do sodium and fill up sodium. I know that sodium is on the third period, right? So, and he has 11 total protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So anyways, I just drew all the electrons. I said it has 11 protons. An atom like this guy, a neutrally charged atom, will have 11 electrons because of the 11 protons. When it forms these chemical bonds, so sodium oxide is what that first box is, Na plus O, okay? We're only on sodium and oxygen when we start doing these chemical bonds, we're only going to show this valence shell if I haven't made that clear already in these previous videos. So that might be a little confusing to you guys, and I apologize for that. We're only showing this valence shell. Okay, oxygen, we're only going to show its valence shell. So this is what it's going to actually look like when we start doing the bonding. Okay, is I have a sodium that has 1 valence electron. Okay, I have oxygen. Oxygen actually has 6, and this is how I do these guys. I put 1. I treat the element like it's a square. Okay, there's 4 sides to it, so I'll put 1 on this side, 2, 3, 4, 5, and 6. Okay, so we can see automatically that we have 2 open spots. Okay, and so we know that oxygen's a nonmetal. We just got done talking about nonmetals like to accept. They will take electrons, and so where will they take from? They'll take from metals like sodium, because sodium wants to give up an electron. And sodium will do that. However, sodium only has 1 electron, and it gives it up to oxygen. Oxygen would still like 1 more, and so therefore we need another sodium atom to join. Okay? And that sodium atom right there will join. So we actually need 2 sodiums in here to make sodium oxide. How this is going to look, so if you don't have this drawn yet, like this, that's fine, because I'm not going to grade this, the chemical bonds portion today. I'm not going to grade that when you guys turn that in, but I'm going to give you the assignment today after this. That's going to be due for Wednesday. I will start grading those chemical bonds. So what the end product, so this is like step 1, right? This is how we figure out, all right, sodium's giving 1 electron, sodium's giving 1 electron here to oxygen. Oxygen now has 1, 2, 3, 4, 5, 6, 7, 8, right? And sodium lost its 1 electron that it wanted to. Sodium lost its 1 electron like it wanted to, right? If we go back to our table that we were just looking at, that we just got done doing, right, we see, where's sodium at? Sodium, right? So sodium has 1 valence electron. It will always give 1 electron and make it positively charged. Okay, and what do we have here? Oxygen. And so we know oxygen right here has 6 valence electrons. It will always take 2 electrons and become -2. Okay, so that's why we did this table here. Okay, so anyways, what your finished product will look like I said, if you already did this today and whatnot, I'm not going to mark off on it, but starting on Wednesday when I do grade the next assignment, the end product. So step 1, I still want to see step 1. How did you get this figured out? Step 2, okay, I want you to go ahead and we're going to put, I'm going to erase this real fast. This is going to be step 2. Okay, step 2, so I have only 1 oxygen molecule, or I have only 1 oxygen atom, so I'm going to put him in the middle because there's 2 sodiums. So we know oxygen has, oh, I don't have to worry about the valence electron, sorry about that, and I'll go ahead and put brackets around him. Okay, and so what did we just say his charge was? Well, oxygen's charge is going to be -2 because he got 1 electron from 2 sodiums. Okay, so sodium is positively charged. Remember, he gave his electron to oxygen, and then this sodium over here is in brackets and he's positively charged, okay? And this right here is going to be your final answer, okay? This is going to be that finalized answer. It looks a lot neater sometimes, like in class here, some kids, when they do those, they have the dots and they draw the arrows like I was doing, they'll draw them all the way around and the pictures just look terrible. So this will be the finished product, but I still want to see that step one that I had before this, so I can see that you know how to work it out and understand where these electrons are coming from, okay? So why is this guy -2? Because he gained a negatively charged electron from here, gained another negatively charged electron from here, making him +1, And it's ionic because now these ions are oppositely charged. Positive, positive are attracted to this -2. Okay, so that's sodium oxide. And so you hear me say oxide or sulfide or chloride. If you notice, those guys are all nonmetals, and anytime they form ionic bonds, you start to call them "ide." You put "ide" at the end of them. All right, I just need my computer to cooperate. Okay. All right. What's our next one here? What's our next one? Calcium chloride. So calcium chloride is going to be similar. Plus chlorine. So calcium, we know it's a group 2 element. Okay. So calcium has 1, 2 valence electrons. It's group 2, therefore it has 2 valence electrons. We know chlorine is a group 7 element, so it's going to have 7 valence electrons. So I'll have chlorine here. And again, if you guys, I have these different colored things and stuff like that. I don't know if you can see green all that well. If I have purple up here. Oh. So if I have chlorine, 1, 2, 3, 4, 5, 6, 7. I like to keep the 1 lone electron facing him. So I know that, again, metals like to give up their electrons. Chlorine is close to becoming a noble gas. And how's it going to do? It's going to gain 1 electron, and chlorine or calcium wants to do the same thing, except it wants to lose electrons, right? And so, well, what's going on with this guy, right? How come we just don't give him to chlorine? Well, remember, chlorine can only accept up to 8, right? In his valence shell, he can only hold up to 8. If we gave this one over here, there would be 9, and that's not possible. That doesn't work in science. Okay, so what do we have to do? We have to add another chlorine. So let's get another chlorine in here. Chlorine. 1, 2, 3, 4, 5, 6, 7. Okay. And that electron will come to here. And so this will give he gave away electron, gave away 2 negatively charged electrons, right? So we'll have a +2 charge here for calcium. We'll have a negatively charged chlorine and a negatively charged chlorine. Okay, so what's that going to look like? The final product, right? Let's draw our brackets with the final product. So we want to show that calcium is bonded with this chlorine and this chlorine's bonded with this calcium, right? We don't want to show that chlorine here is bonded to this chlorine and then is bonded to calcium. That's not how it works, right? Because this electron went to this chlorine, that's the chemical bond. This electron went to this chlorine, that's the other chemical bond. And we want to show that one in our final product. Okay, so we still have our calcium 2+, and then we have our chlorine negative charge, chlorine negatively charged. Okay, I guess it doesn't matter where we put that. Okay, so again, this will be your final product. Something else I told the other guys, the classes, is if I add up this part right here, all right, my negative plus a negative plus 2 positives, that charge will give me 0, right? So if I add up my two negative charges, that's -2, and then I have my +2. They cancel each other out, and that's fine. Like that's what we want, right? So there's calcium chloride. Let's do that third one. Do a couple of these problems together here. And computer's freezing up here. All right, there we go. A little late. Sorry about this, guys. Magnesium sulfide. And if you're having trouble keeping track with like how the heck is all this, how does he know how many valence electrons are right? Make sure you guys have a periodic table out and you're looking at the groups. We're looking at the groups right now. The groups are the columns, right, that run vertically. And so group 1, all those guys have 1 valence electron. Group 2, all of those guys have 2 valence electrons. We skip the transition elements and then we go into group 3. That starts off with boron at the top and then aluminum. So we had magnesium sulfide. Sulfur, we know this is a group 6 element. This is a group 2 element. So we have 2 electrons here. We have 6 over here. We want to give 2 electrons, and this guy wants to take 2 electrons. So this one's fairly simple here. We have magnesium, 1, 2. We have sulfide, 1, 2, 3, 4, 5, 6. And so it's pretty simple here. There's 2 open spaces, right? He needs 2 more to get to his 8, and he needs to lose these 2 to bump down that energy level and have a full valence shell from that previous energy level. So these guys will go ahead from magnesium and be given up and be given to sulfur. And that calls it magnesium sulfide, right? Nonmetals, when they form ionic bonds, you put IDE behind them, sulfide. Okay, so how does this look in our finalized form? And G brackets, he gave up 2 negatively charged particles, so he gave those away. So now he is +2. And then sulfur gained 2. Right? So if it gained 2, now it is negatively charged. Okay? Some of you guys have probably noticed I don't put the electrons around my atomic symbol anymore. Well, this bracket here shows that this has a full valence shell, and this is my charge, right? This is how many extra electrons I have, or how many electrons I lost. If it's positively charged, you lost electrons. If it's negatively charged, you gained electrons. Okay, so that's magnesium sulfide. The next one, you guys were not assigned, but we'll go ahead and do this one together anyways because it's probably a little tougher. It's aluminum chloride. Okay, so if you guys want, you can go ahead and pause the video, try to do it by yourself really fast. I'm going to go ahead and do it, and then you guys can look at it after you get done pausing it. I know aluminum is a group 3 element, therefore it has 1, 2, 3 valence electrons. Chlorine, so, right, he's a metal, he has 3. He's going to give 3 of these electrons away. Chlorine has 7, so he only needs to gain 1 more valence electron to achieve that 8 valence electrons. So then I have my chlorine here. Let's see, let's start here. 1, 2, 3, 4, 5, 6, 7. So we have our empty spot right here. 1 electron will be given there. So we still have these 2 to give up, right? He's got to give up 3 electrons. So what do we need to do? We need to grab 2 more of these guys because they only have 1 available space, right? It's like a hotel. It's a vacant. This is a vacant room for a hotel, and a hotel always wants full rooms. So we need to grab some more chlorines with 1 space to fill. So here's our chlorine. 1, 2, 3, 4, 5, 6, 7. Again, he goes there. Now we have 8. I need another chlorine to take this guy. 1, 2, 3, 4, 5, 6, 7. And again, this aluminum electron. So if I go ahead and count, I gained 1 electron. 1, 2, 3, 4, 5, 6, 7, 8. Right? All of these chlorines now have 8 valence electrons. Aluminum lost its 3, and it bumps down that energy level where it does have a full valence shell there. Okay, so again, how's this guy going to look? We have 3 here, so it's going to look a little different. So aluminum, they're all 3 of these chlorines are still individually bonded to aluminum. Charged, negatively charged, and then we have our aluminum, which is +3. Okay, and so here's our final step, and that aluminum chloride. Okay, +3. If we add up all of these negatives, we have 1, 2, 3 negatives, and that offsets that +3, and so our charges overall for this molecule 0, right? So again, when you guys do these next two, you guys need to make sure you have step 1 and step 2. It's kind of like a math problem, okay? I don't want just the right answer. I want to see how you got to the right answer. Okay, and then there's 2 at the end on that bottom row right next to this example that say do it on your own. How about we do, let me erase this real fast. How about we do sodium fluoride? You guys will do that one for one of them. And then let's do lithium phosphide. So we have lithium plus phosphorus. Phosphorus is, atomic number is 15. So that's a lithium and that's a P, phosphorus, if you can read that. Okay, so this is ionic bonding. So remember, ionic bonding is this giving away of electrons, and the nonmetal is accepting the electrons. Let's get back to covalent bonds. So there's 2 types of bonds. We talked about covalent bonds at the beginning of last week, and then we've been just kind of finishing up on ionic bonds. So if you guys go to the next page, all right, there it goes. You guys go to the next page. We scroll down. Okay, you guys, we're going to do these ones together, okay? So hydrogen to hydrogen, hydrogen to chlorine, and chlorine to chlorine. So this is so remember covalent bonding is sharing. We share electrons to achieve octet, to achieve that full valence shell. That's what octet means. If you think of octet, octo means 8. Okay, so I have hydrogen here, and hydrogen only has 1 electron on its valence shell, right? If you look at your periodic table, hydrogen is in the first period, and so the first period elements only have 1 energy level, and that 1 energy level can only hold a max of 2 electrons, where then after that they can all hold 8, up to 8. So then we have another hydrogen over here, okay, and I'll make that an X so we can tell the difference. But anyways, this hydrogen would like to get a full valence shell by adding 1 more, and this hydrogen would like to do the same. And so they can do something. They can share these 2 electrons so that they achieve their full valence shell. And so they'll go ahead and do that. This hydrogen's energy level will overlap, and so now this hydrogen has 1, 2 valence electrons, right? And this hydrogen will do the same. It'll take its energy level, it will overlap, and now this hydrogen has 2 valence electrons. That's them sharing their electrons. Okay? So there's that first one. That's how that should look. So recognizing covalent bonding, we're showing how these energy levels overlap and show this electron. So this is what that our final product will look like, opposed to ionic bonds, where we had the brackets. We had the brackets, and we had positive, and we had negative, and we had charges. Okay, because remember, ions, we just got done doing ions. Ions are charged particles where atoms are neutrally charged. Okay, so there's hydrogen. That's what the gas, H2, hydrogen gas, that's what it actually looks like. See if my screen will move with me. Then we had HCl. And then we had chlorine. Okay. All right, so let's start with them right here. So we know that hydrogen can only hold up to 2 valence electrons. Chlorine has more than 1 valence electron. It actually has 3 energy levels. Or he only has 1 energy level, where chlorine has 3 energy levels. So energy level 1 will only hold up to 2 electrons, and after that he'll hold 8, up to 8, and he'll hold up to 8. Okay, so again, we're only drawing the valence shells, or the valence electrons. And so chlorine, again, is in group 7. That's where we have 7 valence electrons. So we'll go into the start. 1, 2, 3, 4, 5, 6, 7. Okay. Well, this all works out really well, right? Hydrogen would like to get 1 more, and chlorine would like to get 1 more, right? So they'll just share these 2 electrons with each other. So if hydrogen, his energy level overlaps, he ends up sharing these 2 electrons. So he has 1, 2 valence electrons, and he's happy with that because that's on his first energy level. Chlorine, right? This is his 3rd energy level. And he will end up having his energy level overlap with hydrogen's. And now this electron is also with chlorine. So 1, 2, 3, 4, 5, 6, 7, 8. Now they're both happy. They both have full valence shell, and they did it through sharing each other's electrons. Okay? So there's that one. So you guys need to write these down. Make sure you know what's going on. Let's go ahead and do chlorine. Okay, so I have chlorine, and we just said that chlorine, guys, they have 7 valence electrons. Okay. Let's see here. All right, so chlorine has 7, needs 8. Chlorine has 7, needs 8. So why don't they just share these 2 electrons right here? So let's go ahead and do that. This chlorine right here. 1, 2, 3, 4, 5, 6, 7, 8. He's happy. This chlorine will do the same, and we'll draw that energy level around this 1 electron. Right? And remember, electrons like to form in pairs. That's why we're drawing these guys also. When electrons form chemical bonds like this, they do so in pairs. You will not make a chemical bond with 1 lone electron from one atom or the other. Okay? So anyways, that's what, Cl, that's what chlorine gas looks like. That's poisonous. Okie dokie. So what's next? So then I assigned a couple more to you guys. Okay. And so now what I want you guys to do, I want you to do hydrogen oxide, hydrogen nitride, and hydrogen carbide. Okay, so you guys have this middle row here. It's the middle row that your guys' bottom row, for whatever reason, jumped down here. But you guys go ahead and finish this up for Wednesday. That's due after Election Day. We don't have school on November 2nd because of Election Day. I will grade these for a grade, okay? So it will not be participation anymore. So hopefully we're getting better at that. That's what you guys have to do. There's also one other thing. You guys probably have seen the Blingzinger article. This guy right here, it talks about lead and all of the applications that lead had in there. So it just talks about jewelry at first, but then lead is actually used or was used. We got it out of everything, but we used it in plumbing. We used it in paint. It was actually a sweetener at one time. We used it in ancient pottery glazes and stuff like that. So there's a lot of applications, and that's what this article talks about. And then you guys will end up filling out this questionnaire, or this, sorry, just a worksheet. Fill up this worksheet and submit that by Wednesday. If you guys have any questions, please let me know. If you guys, I'm going to get your guys' quizzes graded to this evening, and you'll be able to see them this evening. Bye.